The first audio lecture covers the history of evolutionary theory. Evolutionary theory is interesting because when you look at it, there's a broad spectrum of life on Earth. You need to encapsulate both ideas about Earth and its history, how Earth came to be geologically, but you also need to think about the nature of the universe. So what I have compiled is kind of a history and development of evolutionary theory that starts off by looking at, the early ideas about nature and life of the universe, to start kind of the universe, as well as bringing in some of those ideas that look at reproductive continuity as a species and species changing over time through generations, and those traits kind of persisting. Those are evolutionary ideas. Sometimes they're not easy to recognize, and they're blurred with things like ethics and religion, but much of it has to do with moving away from creationist type ideas that even still persist into today. The development of evolutionary theory is not the easiest to track, and we have to look at when we have some written records, but much of it kind of traces back to, at least that is documented, is Aristotle, 4th century BCE, very famous Greek philosopher, and what he had mentioned was a concept known as the Great Chain of Being. The Great Chain of Being, or Scala Naturae, as it was, I believe, originally dubbed, it discusses a progression of lower to higher organisms. I believe Aristotle's, upper echelon of the Great Chain included a higher being, humans, and maybe they recognized the similarity between us and other primates, monkeys or apes, other rodents, reptiles and birds, and then small things like nematodes and worms. That there is maybe a progression, that there are ones that are cognitively not as having the type of acuity that we have, all the way down to other organisms that don't have something like a central nervous system or cognitive abilities to the degree that we do. This kind of ranked organisms into ones that were kind of inferior and others that were superior, which is strange. We don't think about it this way in evolutionary biology. We kind of think that every organism is adapted to its specific environment, and we couldn't certainly outcompete gorillas at the base of Mount Kilimanjaro, and so they are the most adapted to their environment. They are not lesser or higher, in comparison to us. Matter of fact, we're inferior if we try to. So it sounds silly now, but maybe they were thinking about the progression of organisms that we would see evolve over time, that we do notice when we look at evolutionary relatedness of these organisms. That, for instance, nematodes and other worms, they evolve first. We know that lizards and birds evolve, probably lizards first, then birds, and then mammals. So it's a small rodent like the largest rodent, actually, like a capybara that's pictured in here. Yeah, so this would mimic the evolutionary charts that we do have, but we don't describe them as lesser or higher organisms. When the Great Chain of Being was published and disseminated and popularly adopted, there was a number of suppositions of the Great Chain, of the Scala Naturae, that followed. And this is some of it verbatim that Aristotle said, like the Earth being full and it's totally complete. Species are fixed. If species are fixed, that means that they are all the same in some ways, and they will not change over time, and therefore there is no change. And this is a creationist type of idea, and it breeds arguments later, like a teleology. This is purposeful or goal-oriented, where evolution has a set end goal. We can think of the end goal with all the other species that are intermediary between apes and us as us, with a few other hominids like Neanderthals that went extinct along the way. But evolution doesn't have a purpose. It just it's just evolution. Organisms adapt and evolve. Whether you see it as transforming into something better in your way, it's the environment that dictates it. And teleologies with some type of goal orientation also breeds arguments like orthogenesis, that you have some type of predetermined path of existence. And this is that, your whole path of your life is mapped out for you. And so is, creation and life on earth, if it's all just fixed and created in some ways. There's also arguments of essentialism, that there's unchanging aspects of an organism, and somewhere there's the perfect representation of it through maybe even a higher being, and the variation in it isn't really important because it's perfection in accordance with that higher being, and so it's not necessarily important to study. And this is contra to everything in evolutionary biology. All we study is variation. Variation is very important. You also notice that variation in humans, both in biology and culturally and ethnically, is actually really important for us. Aristotle's view of the world and organisms persisted much for maybe even 1,000 years or less, and it actually kind of set back some of these other important ideas about the nature of the universe, as well as how life has evolved and changed. But there were other thinkers like Ptolemy, and Ptolemy was one of the generals of Egypt and Alexandria because the Greeks and the Romans successively conquered and sacked Egypt and took it over. Well, he was a mathematician. He was also a philosopher, and what he had proposed, as a hypothesis, he was interested in mathematics, and he had ideas to back up his, theorems to back up his ideas. But he had suggested that the Earth is the center of everything in the universe, and this is typically known as the Earth or planet, center, the geocentric model of the universe and celestial bodies, that you have Earth and everything revolves around it, including the sun and all the other celestial bodies that many people were even observing in space at this time with makeshift, mathematical computations and theorems. And many people believe this for, again, maybe even another 1,000 years, until you had a number of individuals that began making more sophisticated instruments like telescopes to view celestial bodies. While Ptolemaic cosmology seems as the mainstay for several hundred years, if not more, you have Europe in a bit of disarray heading into the Middle Ages, while at the same time you have Islam reaching a golden age between about 800 to 1300 CE, where at the House of Wisdom in Baghdad, the center place for some of those prominent scholars all over the world, they begin debating the nature and composition of the universe, like Nasser ad-Din Tusi, and they start thinking about, how particles come to be, how particles interact with each other, and, this is different from just accepting that there is the geocentric model of the universe in celestial bodies, that the Earth is the center of the universe, and that's it, and everything's fixed and full. We don't necessarily need to think about it or study it. Around 1503 or so, it is a Polish astronomer, Nicholas Copernicus, who begins working on an entire theorem we consider a hypothesis, that it is in fact the sun that is the center of the universe or solar system that we now know, or heliocentric model of the universe and celestial bodies. The sun is the center, and that there are celestial bodies like Earth and other planets that revolve around it. And this was an interesting idea. It was contra to a number of other earlier models, like the geocentric model of Ptolemy, But many people were recognizing, like Copernicus, that the Earth had a number of different motions. At this time, they had a good handle on knowing that the Earth, in fact, had three motions. One, that it actually was spinning, that it rotates, that it actually wobbles a little bit because it spins, kind of like a top does when you spin a top on a level surface. And then the other motion that Copernicus was really trying to get people to support was the motion around the sun. And he was able to write his treatise, and other people did find interest in it. But it was, of course, not supported or rejected. And it is maybe 100 years later that people really confirm Copernicus's heliocentric model. Enter in Galileo Galilei, who at around the 1600s, he actually repeated and solidified Copernicus's ideas. He made a number of different breakthroughs in telescope construction and began viewing a number of different celestial bodies in space revolving around each other. Namely, he's most popular for discovering the Galilean moons of Jupiter, these 4 moons depicted right here, the largest moons of the 60 some odd moons that Jupiter actually has. He noticed them revolving around Jupiter, and he suggested that there has to be other celestial bodies revolving around each other all over the universe, and that the sun is the center of that, with these other planets actually revolving around it, including us. Galileo's ideas were not accepted. They were actually Galileo was excommunicated from the Catholic Church. He was jailed. It was during the Spanish Inquisition. And so if you notice that even having some of these ideas that are contra to the popular ideas today may have gotten you in a lot of trouble in your career, and you would have not led a very happy and long life. But understand that what people are doing here up until before the European Enlightenment is they are trying to challenge ideas by finding evidence to reject them. And it looks like Copernicus and Galileo did a really good job of being able to reject that the geocentric model of the universe is not correct. And once we were able to look at how dynamic the universe was, people started looking at the next question was, how did life evolve then?